Surfside condo collapsed, the Leaning Tower of Pisa, San Francisco sinking Millennium Tower. These big events that happen around the world may all be caused by one thing: subsidence. On June 24, 2021, around 1:20 a.m., half of the condos suddenly collapsed. The rescue went on for weeks, and finally, 95 deaths and 2 missings write a period for this event. Although the tragedy cannot be directly concluded from the satellite images, Miami Beach have suffered a 1 to 3 centimeter subsidence per year. The area where a building partially collapsed in Surfside, Florida, showed signs of land subsidence since the 1990s. What can we do to avoid these tragedies? Fortunately, we already have a potential solution called the synthetic aperture radar. What on earth is synthetic aperture radar? Synthetic aperture radar, or SAR, is a remote sensing tool that sends microwaves toward the Earth and collects a bounce-back radar signal that describes physical features. It acts like a bat circling around the Earth and repeatedly sends microwaves toward the ground. Its ears collect bounce-back waves and create a clear view of what happened on the ground. What differs the synthetic aperture radar from others is that it used the spacecraft motion along with advanced signal processing techniques to stimulate a larger antenna. The device can rival the resolution of a 100 times larger antenna radar. Millennium Tower in San Francisco encountered the same problem as Surfside condo.
It has been confirmed over years that the building continued to sink for a few centimeters per year. Sentinel-1 satellite, when observing subsidence, used some more specific radar called the INSAR. INSAR, or interferometric SAR, compares phase difference between two complex radar SAR observations of the same area. INSAR focused more specifically on terrain deformation. The satellite sends C-band waves that have a frequency of 4 to 8 GHz and a 7.5 to 3.8 centimeters wavelength toward the city. The waves successfully went through the skyscrapers, passing obstacles to touch the ground. Then, the wave bent back toward the space, losing some signal in the air, but some eventually returned to the satellite. After combining the phase of two images with differential interferometry, or DINSAR, it showed an up to 20 mm per year subsidence. This technique works well with buildings since it better reflects the radar beam. The same technique is even applied to larger-scale subsidence detection, exemplified by its employment in the whole Bay Area. The Bay Area surroundings mainly have a green feature that says no displacement or movement, but closely around the coastline, especially around San Rafael Bay, subsidence is currently visible in red and orange. Being the high-tech area of the United States, it is hard to count economic loss if a large collapse happened again in the Bay Area.
Another place with a similar problem as the Bay Area is Shenzhen, China, which had been observed subsiding since the 1980s. Both the Bay Area and Shenzhen are located around the coast. Geological displacement and subsidence are more extreme around the coastline. The purple dots in the graph indicates an up to 25 mm subsidence per year. If Shenzhen and the Bay Area collapse due to the subsidence again, the economic and scientific loss will be uncountable. As synthetic aperture radar techniques evolve, they can create a huge benefit for human society, especially in the detection of geological movements, like subsidence, displacement, or ascension. For all of the city subsidence, we can all find out that the SAR can play the main roles as warning inside. The Nether satellite that is planned to launch in 2021 will return a tremendous amount of data. Indubitably, the widespread use of SAR will provide better protection for people in the future.